Lesson number 5. Equations in quadratic forms. Now, we have the following quadratic forms that could be transformable into quadratic equation. So, here are the patterns. Here we have ax to the power of negative 2 plus bx to the power of negative 1 plus c is equal to 0. Next is ax plus b square root of x plus c is equal to 0. And third, a times the quantity of x minus d squared plus b times the quantity of x minus d minus c is equal to 0. And we have the fourth one, ax to the power of 4 plus bx squared plus c is equal to 0. And take note, your a must not be equal to 0 because again, that will determine if the equation is quadratic or not. So that's an important pattern that we need to remember. Your a should not be equal to 0. We have the practical examples of what we have mentioned in the previous slide. We have now the practical application of those equations. The previous one were patterns. This one is the real example. So we have here number 1. This is an example where this equation may not look like a quadratic equation, but we can transform this one into a quadratic equation. So we have also number 3, number 4, and number 5. So all of these examples, as we can see, they may not look like a quadratic equation, but we can transform them into quadratic equation and solve for the value of x. So now we have the steps in solving equations transformable to quadratic form. So first step is standard form. That's your clue. Always change the equation into standard form. Second, rename. That's your clue. Rename the variables to transform the quadratic equation or the equation to quadratic form. And the third one is appropriate technique to solve. That's your clue. Appropriate technique to solve. Because in every given problem, you have the options what technique you'd like to use to solve the value of x. As we discussed in the previous lesson, we have 4 ways how to solve quadratic equation. It could be extracting the root, it could be completing the square, it could be quadratic formula, or it could be factoring. So those 4 techniques, it depends upon what is comfortable with you. You can use any one of those as long as you'll get the correct answer to the values of x. And lastly, you need to check for extraneous roots. When we say extraneous roots, that means those values of x that will not satisfy the original equation. That means when we substitute the value of x after we get the values of x, there will always be 2 values of x. So we will test them. That's why the last step there is check or test them if they will satisfy to the given original equation. If they will not satisfy, then they are called extraneous roots. Okay, so that means that value of x is not a solution. But if when you substitute the values of x will satisfy the given original equation, then that means it's a solution. Okay, so that means there is no extraneous roots in the values of x that you have found. Okay, so remember those key ideas? first step is standard form. Make sure that it is in standard form. Second is to rename. Third is find the appropriate technique to solve, and check for extraneous roots. We have now example number 1. Find the roots of this given equation. X to the power of negative 2 minus 7x raised to the power of negative 1 equals 12. So based on this given, the first step is standard form, always. So transform it into standard, so this will happen. You transfer 12 to your left side, negative 12. So that will become plus 12 is equal to 0. So we have now the standard form of the equation. So what will be the next step? Rename. Okay, very good. So rename. How will we rename? Okay, this will happen. So the x to the power of negative 1, we will assume that that will be our letter u. Okay, so sir, why did you use letter u? Why not other letter? Yes, for me, I am comfortable using letter u. But if you would like to use another letter such as A, such as B, C, it doesn't matter as long as you are renaming it with the same letter. U is equal to x to the power of negative 1. Then u squared is equal to x to the power of negative 2. So if you are using A letter, let's say A is equal to x to the power of negative 1. Then A squared is equal to x to the power of negative 2. So only use same letter when you rename. Do not use different letters. So A is equal to x to the power of negative 1. Then B squared is equal to x to the power of negative 2. That's a no-no. For sure your answer will be wrong. So again, use same letters. As long as they are the same, granted that you are following the correct process, I can guarantee that you will get the correct answer. So now, after we rename, we will substitute. We go back to the equation in the previous equation where we had the standard form, and then substitute the letter that we use in renaming the variable. So here we have now your x to the power of negative 2 will become u squared, and then your x to the power of negative 1 will be u. So you have now quadratic equation. U squared minus 7u plus 12 is equal to 0. So after we substitute, what's next? Factor. So this is now the appropriate technique that you will use. It depends on you. You can use quadratic formula. You can use completing the square, as long as you can solve the values of x, or the values here, the letter that is being used is u, to find the value of u. So the factor in this trinomial, we have now u minus 4 times u minus 3 is equal to 0. That's the factoring. Now, after you factor, then that's the time you equate it to 0 and solve for u, the one we learned in the previous lesson. So we will apply those. So equate it to 0 and solve for u. So first, we have u minus 4. So it's very easy. Transpose 4 to the other side, then that will be positive 4. So that's the first value. And then second value will be 3. So the first value of u is 4, and the first value of the second value of u is 3. So now, what's the next? Next one is to check for extraneous roots. So we will test those two values, which is, the first one is 4 and the second one is 3. So now we have here, substitute the value of u to the original variable, which is x to the power of negative 1. So we will substitute here, as you can see. So u is equal to 4. Then now, since u is equal to x to the power of negative 1 in the renaming that we had a while ago, so that will be, we will change u into x to the power of negative 1. So x to the power of negative 1 is equal to 4. And then when we say x to the power of negative 1, that means we will change that one into fractional form because the equivalent of x to the power of negative 1 is fractional form. Okay, what will be the fractional form of x to the power of negative 1? As you can see in here, 1 over x. Okay, so 1 over x. That will always be the case. Okay, so 1 will be always the numerator and the variable with the negative exponent will be the denominator. So in here, the variable is x raised to the power of negative 1, so that will be your denominator. 1 is constant. That will always be the case. And then copy the one that we had find for u, that is 4. Then continue simplifying. What have you learned in this case? If you have fraction and then whole number with equality symbol, you remember the one that I taught you? Just simply exchange the position of your x and the number 4. Just simply swap their position. So when you swap, this will happen. So x is equal to 1/4. And when you substitute 1/4 to the original equation, it will satisfy the equation. So we will mark here solution. That means it will satisfy. Second is u is equal to 3. Same thing we will do. Change u to x to the power of negative 1 because that's what we did a while ago. And then is equal to 3. Then again change into fractional form. So 1 over x. And then swap the position of number 3 and x. Again, the numerator 1 will remain there. You will not anymore touch it. So exchange the position, swap. So you have there x is equal to 1/3. And again, when we substitute 1/3 to the original equation, the answer will satisfy the given equation. So it's a solution. So that means in this example, we don't have extraneous roots. Both values of x are a solution to the given equation in example number 1. So now we have example number 2. Still find the roots of this given equation. So we have 3x raised to the power of negative 2 minus x raised to the power of negative 1 is equal to 10. That's the given equation. So now, what's the first step? Standard form. So change it into standard. So here's what happens. So your positive 10 will be transferred to the left side of the equation. So that will become minus 10 now. So we have now standard form. After we have the standard form, then proceed to renaming. So renaming, you have, okay, same thing what I did in example number 1. Letter u equals x to the power of negative 1. Then u squared is equal to x raised to the power of negative 2. So next, after you rename, then substitute to the previous equation in standard form. So change x negative 2, then x negative 1 to letter u. So you have now quadratic equation. 3 u squared minus u minus 10 is equal to 0. Okay, so now let's continue. Appropriate technique. What will be the appropriate technique? For me, it's factoring. If you can do other thing, it's okay. If you want to do completing the square or quadratic formula, it's okay. As long as you will get the correct answer. So here, we have factoring. So you have 3u plus 5 and then u minus 2 is equal to 0. So you have to equate. Just like in example number 1, equate it to 0, then solve for u. First, you have to transpose 5 plus 5, that will become negative 5. So 3u is equal to negative 5. And then divide it by 3. Eliminate the number beside the letter. The number beside letter u is 3. So divide it by 3. both sides. So 3 over 3 cancel, and then negative 5 over 3. So u is equal to negative 5 over 3. That's the first value. Second value is that u minus 2 is equal to 0. So just simply transpose 2 to the right side. So we have u is equal to positive 2. Again, we have, last but not the least, check for extraneous roots. So first, substitute the value of u to the original variable, which is x to the power of negative 1. So you have here u is equal to negative 5 over 3. So again, you change u into x to the power of negative 1. So you have negative 5 over 3. Then change the variable with negative exponent into fractional form. So you have now 1 over x is equal to negative 5 over 3. So now, if this is the case, a while ago, I told you to swap the position because the other side is fraction, the other side is whole number. Just simply swap. This time, both are fraction. So what will we do? Just simply cross multiply. Cross multiply. Okay, so that means 1 times 3 and then x times negative 5. So what will be the answer after we cross multiply? So this is the answer. 3 is equal to negative 5x. And then, since we need to eliminate the number beside the variable, so divide it by negative 5 both sides. So you have there, divided by negative 5, cancel. So what will remain is x is equal to 3 over negative 5. And when we substitute this value to the original equation in the given, we will satisfy the equation. So it's a solution. Next, u is equal to 2. So change u into the given variable a while ago. We rename. So x to the power of negative 1 is equal to 2. Then change that we negative exponent, the variable, into fractional form. So that will be 1 over x is equal to 2. And then again, this one is swap. Just simply swap because it's fraction and whole number. Swap the position. Okay, so that will be x is equal to 1/2. And when we substitute, it is a solution. Okay, so again, you need to substitute that value of x to the given original equation in order for you to conclude whether it is a solution or not. So we have now example number 3. Find the roots. We have the given equation. Quantity x minus 5 squared minus 10 quantity x minus 5 is equal to 24. First step, we have to transform into standard form. Then, we have now the standard form. After we transform into standard, then we need to rename. So, what will we do? What will we do with the renaming? So, you have let u is equal to x minus 5. And then, u squared is equal to x minus 5 squared. So, after you rename, so that will be the renaming. Then, substitute. So, substitute it in the previous equation, the let u there. So, u squared is equal to 10u minus 24. Again, u squared minus 10u minus 24 is equal to 0. Then, same thing. And for me, I'm okay with factoring, so I will factor this one. So, you have here u minus 12 times u plus 2. Then, equate it to 0, then solve for u. So, we have now u is equal to 12 and u is equal to negative 2. And then the last step will be, so we have here the last step, check for extraneous roots. So, we have here, substitute the value of u to the original variable, which is x minus 5. So, u is equal to 12, then change u into x minus 5. So, x minus 5 is equal to 12. And then transpose 5. So, that will be x is equal to 12 plus 5. And then the value of x is equal to 17. And when you substitute 17 again, it's a solution. Next is u is equal to negative 2. Then change u into x minus 5. So, x minus 5 is equal to negative 2. Then transpose negative 5. So, that will be x is equal to negative 2 plus 5. Then x is equal to 3. And then when you substitute 3 to the original equation in the given, the answer is also a solution. It will satisfy the given equation. So we have now example number 4. 3 times the quantity of x plus 4 squared minus 7, the quantity of x plus 4, is equal to 6. So first step, transform. Okay, transform it. Then, after we transform it into standard, then we need to rename. So rename it. Let u is equal to x plus 4, then u squared is equal to x plus 4 quantity squared. After that, substitute. Then, here's what happened. 3u squared minus 7u minus 6 is equal to 0. Then for me, again, is factoring is okay for me. So I can continue. 3u plus 2 times the quantity of u minus 3. So find the value of u now. Equate it to 0. So you have 3u plus 2 is equal to 0. Then the value of u, simplify, u is equal to negative 2 over 3. And then the second is u minus 3 is equal to 0. U is equal to 3. After this, check for extraneous roots. So here we have to check for extraneous roots. So substitute the value of u to the original variable, which is x plus 4. So you have here u in the previous process, u is equal to negative 2 over 3. So that u will be changed into x plus 4. So you have now x plus 4 is equal to negative 2 over 3. Then transpose 4 to the other side. So that will be x is equal to negative 2 over 3 minus 4. So in here, simplify. So get the LCD. So the LCD of negative 2/3 minus 4 is 3. Okay. The denominator, just simply copy the denominator. 3. And then the numerator, copy the negative 2, and then the second number, just simply multiply the denominator and the whole number. So the denominator is 3, the whole number is 4. So multiply them, 3 times 4 is 12. Okay, that is why there you have negative 2 minus 12. Where did we get the minus in between 2 and 12? Is the operation in between in the previous process. So that is minus. So minus 4, that will be minus also. So negative 2 minus 12 over 3. Simplify. So you have negative 14 over 3. And what will be what will be the decision for negative 14 over 3? That will be solution. Next is u is equal to 3. Again, you change it into the original equation. The renaming. X plus 4 is equal to 3. Then transpose 4. So that will be x is equal to 3 minus 4. So the answer is x is equal to negative 1. And negative 1 is also a solution. We don't have extraneous root. We have now example number 5. Find the roots of the equation 4x minus square root of x is equal to 5. So it's not really like quadratic equation, but later we can see how it will become a quadratic equation. So first, transform into standard. So there you go. Then after you transform it, rename. So rename. Let u is equal to square root of x, and then let u squared is equal to x. So you have there the substitution. 4u squared minus u is equal to 4u squared minus u minus 5 is equal to 0. Then you have to factor. So the factor is u plus 1 times 4u minus 5. Then equate it to 0, then solve for u. So you have the first one, u is equal to negative 1. And then the second, u is equal to 5 over 4. So now we have to check for extraneous roots. So again, to substitute the value of u to the original variable, which is square root of x. So you have there u is equal to 5 over 4. So change that u into square root of x. So you have square root of x. 5 over 4. So how to remove the square root symbol? Just simply use the exponent. Raise it to the exponent of 2. So you have there square root of x, quantity squared, and then also do it to the other side. Both sides. 5 over 4 quantity squared. Then what will you do? Remove the radical sign. Eliminate also the exponent for the variable. So what will remain is x, and then for 5 over 4, just simply multiply it by itself. Multiply the numerator by itself. That means 5 times 5. So we have there 25, and also multiply by itself the denominator. So 4 times 4 is equal to 16. So, and again, when we substitute this value, 25 over 16, it's a solution. Now, the second one is u is equal to negative 1. So, again, change u into square root of x. So, you have square root of x is equal to negative 1. Then, eliminate the square root symbol. So, raise it to the exponent of 2. Then, what will happen? The remaining is x, and then negative 1 times negative 1 is positive 1. And here now, when we substitute 1 to the original equation, it will not satisfy the given equation. Therefore, the value of x, which is 1, is not a solution. So, in this problem, we have extraneous root. Okay, that means it will not satisfy the given equation. So, even though we find the value of x, but it will not satisfy the given equation. Only 25 over 16. Okay, that's all, and thank you.